This week, you're probably studying collections. And so what I want to do is give you a little bit of context for collections, help you understand what collections are, and walk through a program with you. So first of all, let's just talk about what collections are. In some of your first programming classes, you probably learned about arrays. Primitive arrays in Java are very powerful, but they have a lot of things that are drawbacks, I guess you could say. So one of them, probably one of the bigger drawbacks, is that you can't resize the array. But there are other things too. They're really meant to hold very simple data and stuff like that. So Java has a variety of different collections classes and a framework of collections. So I have here Java's documentation on the collection framework. So there are kind of two things you need to think about. There's interfaces associated with collections and implementation classes associated with collections. The interfaces define a set of behaviors that that particular interface does. So like, for instance, a list has certain types of methods that it implements that define what a list is. And then same thing with set, same thing with map and queue and dequeue and so forth. The actual implementation classes then obviously implement those interfaces or the methods associated with those interfaces. But on top of that, it's really how the data is stored that is part of the implementation class. So for instance, a linked list is objects that are stored with a pointer between them. Thus it's called a linked list. A tree, while it has pointers between them, it's stored in a balanced way so that it's much faster to search. So there's all sorts of different things that kind of come together for the implementation class. So if I look here on Geeks for Geeks, they talk a little bit about the different types of collections. So set, list, queue, dequeue, map, these are, not only are they types of collections, but they're also the interface piece. And then they support, if you look here like set, they support hash set, tree set, sort set, so forth. List supports array list, linked list, and there's some overlap. For instance, a queue also supports a linked list and a priority queue, and a bunch of others. And if you go to this particular documentation, it'll tell you what each of them support. So that's kind of it from the documentation standpoint. Each of these are different, have different uses. A list is really just, let's throw a bunch of objects into a place that I can store them and I can retrieve them later. A queue is, think about a queue as first in, first out, right? And it's always going to behave with first in and first out. A dequeue typically was last in, first out, but the dequeues of today kind of support both LIFO and FIFO. A set cannot have a duplicate record inside of it. So you can't put two of the same thing inside of a set. A map you can't either, but what it typically does is when you go to add the next one, it replaces the duplicate with the last one. So there's some different behavior that's different for each of these. So what I wanted to do was start out by just showing you a quick program. So we're going to start with the most simple of these, and that's the array list. Notice that I've imported javautil.star. That's where all of the collection stuff is kept. And a list, so here is the interface, here is the implementation class, and then I'm calling this list. That's the object name that I've given it. So it's really pretty easy when it comes to a list. I've obviously kind of pre-done this. So I'm going to use the method inList called add. And so I add these different things to the list, and then I can use a pretty simple for each in Java that goes through the list and prints it out. So if we run this, taking a minute here, the result is my list of names. Okay, so I'm going to put a little tag up here because I'm going to put all of these in my program. So for your program that you turn in as part of your familiarity review, you can put all of them in one class or you can put them in separate classes. It's really up to you. I'm putting them all in the same one. So let's look at a set now. Again, a set is a little bit different than a list, and we instantiate it the same, and we add to it the same. Cut them off here. But let's run through this one. Let's see, I need to have my for each in there. All right, so let's run through it. Thinking. All right, so you notice there's one thing different. So in the list here, I have high twice. And for a set, it just didn't allow that one to go in. You can actually capture the result of an add, and this would have sent back I think it's a -1 or a 0, just to say that it didn't pass. So that's something you can do. All right, so let's move on. Talk about a queue. Again, a queue uses a FIFO. And in my example here, I'm going to use a priority queue. The standard priority queue actually orders the stuff in the queue by alphabetically, but it actually puts uppercase letters above lowercase letters. And also what I'm doing here is I'm going to, rather than using this typical for each, which is really slick when it comes to looping through a collection, I'm going to show you another approach, which is to use an iterator. And the difference here is that it has next, which just continues to go to the next, to the next, to the next, to the next. Now, part of the reason why I did it this way is there's this kind of a little weird hang up with a queue. What I'm doing with the queue is I'm adding the elements, and then as I go through, I'm popping them off, or I'm pulling them off. And what happens is that there's not, it goes, so like it starts at 6, and then it goes 5 and 4 and 3 and 2. And the for each doesn't really like that very much. So using this approach, we'll get through all of them. So let's run this one. So if you notice with the queue, it ordered them. So the 2 highs are first, and then my name, and then the rest are ordered in alphabetical order. But it took, when you use this poll, it's going to take the one off the top, and then the next one, and the next one in the priority order. By the time we got to the end of this loop, there was nothing in the queue. Okay? Okay, just a couple more examples I want to show you. So the next one is a map, and maps are a little bit different because they take a key pair. So they take one key that's used to retrieve the data, and then the value that you want to store. So you can use strings or characters, or in my case, I'm just using integers as numbers here as the key. And then the second thing in the put statement is the value that I'm storing. And then it allows me to retrieve a record by the key. Now, I'm also throwing a little hitch in here because if you notice that my last one has the same key as my fourth one, okay? So we're going to have to see what the results of this end up being. So let's run it. So notice I've got hi my name. It should be is, but I replaced it with hi and then Troy. So this particular row replaced this row in the map and including the order. So again, that's a little bit different approach than what we have with these other types. So if you notice, anytime that I'm using one of the methods here, as I'm retrieving data, I have to cast it to the type of data I put in it. So the type of data I put into these are strings, so I have to cast them as a string. And I do the same thing here, I do the same thing here. With this one, Q, I'm not accessing the rows directly, I'm just pulling them off. So it's a little bit different. And I'm using system out, which automatically casts an object to a string. Because the way it is right now, what it's storing here, it is storing an object type, not a string type. And although a string does derive from an object, it's not the same thing. That's why in my for each, I have to say object string. But a bunch of years ago, Java came up with something we call generics. And it's a huge misnomer for what really happens, and that is we actually specify what type of data we're going to put in our collection. So I've created a simple object here, or simple class, DVDs, that has two fields, title and director. It has a constructor and it has a toString. Okay, so I am going to create a list, a lot like the one that I created up here. Okay, I'm going to create a list called myList. Rather than using array list here, I'm using linked list. It could have been array list, but I specify using these brackets what the type is. So these are DVDs. Now, when I add, it already knows that they're DVDs, and it's going to check the type and make sure I put the right type in. So I'm creating a new DVD with the data here. This is using the constructor, and a new one here, and a new one here, and a new one here. Now, in my for each, I don't have to do any casting because it already knows. I can say right here, it's not an object that's being stored, it's a DVD specifically. And I don't have to cast. And on top of all of that, I could do something simple like, say, throw the object at system out print line. It automatically uses the toString method on my class, and the result of that is formatted output. So let's see what happens here. Okay, so here's my list that uses generics. Notice how it's formatted with the title and the director, title, director, title, director, title, director. That is because it's coming again from this toString in this line right here. So this is a fairly simple example of using classes. Obviously, I don't want you to use exactly the same as what I'm doing, but hopefully you can learn from it and be able to write a great program of your own that will use what we've talked about.